Assalamu alaikum, dear students. I hope so you all are fine and you are enjoying good health. I'm your chemistry teacher Sundis Hanif, and today I will teach you chapter first, Fundamentals of Chemistry. And for today our topic is mole and Avogadro's number. So students, first of all, for today, learning objectives. By the end of this lesson, students will be able to understand mole, Avogadro's number. As I told you that atom is the smallest particle of matter. When two or more atoms combine together, they form molecule. Atoms may be or of same type or of different type. When they form molecule, ion is basically when an atom will lose or it will gain the electron, ion will form. Ions are of two types, cation and anion. When atom will lose electron, it will get positive charge and form cation. When an atom will gain electron, it will get negative charge, and this is anion. Okay? Compound and mixture. When the elements combine chemically, they form compound, and when substances combine physically, they form mixture. So this is all about our previous knowledge. For today, our topic is Avogadro's number and mole. Students, the chemical changes observed in any chemical reaction involves the rearrangement of billions of atoms. It is impractical to try to count or to visualize all these atoms, but scientists need some way to refer to entire quantity. They also need a way to compare these numbers and relate them to the weight of substances, which then they can measure and observe. The solution is the concept of mole and Avogadro's number, which is very important in quantitative chemistry. Avogadro's number is an absolute number, and that absolute number is 6.022 into 10 raised power 23. The mass of 1 mole of a substance is equal to that substance molecular mass or molecular weight. For example, the mean molecular weight of water is 18.015 AMU. So 1 mole of water is 18.015 grams. So how can we define Avogadro's number? Avogadro's number is the number of particles found in 1 mole of substance. It is the number of atoms in exactly 12 grams of carbon-12. This experimentally determined value is approximately 6.022 into 10 raised power 23 particles per mole. So students, keep this thing in your mind that whenever the word Avogadro's number comes in front of you, you must click in your mind an absolute number 6.022 into 10 raised power 23. So we can say Avogadro's number is all about 6.022 into 10 raised power 23 particles per mole. Here some daily life examples are present. For example, 1 year has 12 months, 1 month has 30 days, 1 kg equals to 1000 grams, and 1 kilometer equals to 1000 meters. This is very obvious, okay, that 1 kilometer always have 1000 meters or 1 kg always has 1000 grams. This is very obvious. Same like in chemistry, 1 dozen oxygen atom means 12 oxygen atoms. 1 mole oxygen atom means 6.02 into 10 raised power 23 oxygen atoms. 1 mole sodium atom means 6.02 into 10 raised power 23 sodium atoms. 1 mole carbon atom equals to 6.02 into 10 raised power 23 carbon atoms. So we can say that the molecular mass or the molecular weight of all the atoms, molecules or formula unit, it comes equals to 6.02 into 10 raised power 23. That is Avogadro's number, an absolute number, 6.022 into 10 raised power 23. It is understood, it is very obvious that always 1 mole of oxygen atom, it must have 6.02 into 10 raised power 23 oxygen atoms. Clear? Here some other examples are present. For example, 1 dozen oranges means 12 oranges. Maybe their weight is 5 pounds. It means 5 pounds per dozen. Okay. Same is the case that 1 iron atom, its weight is 55.8 AMU. It is only 1 atom. So 55.8 AMU per atom is its molecular mass. 1 mole iron atom, 6.02 into 10 raised power 23 iron atoms, which is also equals to 55.8 grams. So we can say that 55.8 grams per mole. Here I pronounce mole. What is a mole? The mole is the SI measure of quantity of chemical entities such as atom, electrons or protons. We can say the amount of a substance that contains as many particles as there are atoms in 12 grams of pure carbon atoms. So 1 mole contains 6.022 into 10 raised power 23 elementary entities of substances. So the mole is a number, a huge number, but still just a number. A mole is a collection of 6.02 into 10 raised power 23 particles. These particles may be atoms, molecules, ions or electrons. So we can say that 1 mole always contains 6.022 into 10 raised power 23 number of particles. So Avogadro's number and mole, they are very relatable. Okay, 6.02 into 10 raised power 23 particles. Here I took a word particle. As I told you that particles means atom, molecules or ion. Atom is the smallest particle of matter. When 2 or more atoms combine together, they form molecule. These atoms may be of same or of different types. And what is ion? Ion is formed by the loss or the gain of electrons from an atom. So particles may be atom, molecule or ion. If we have any atom, for example carbon, so we can say number of mole atom. If we have any molecule, for example water, we can say number of mole molecule. Or if we have any formula unit or if we have any ion, for example NaCl, we can say it for number of mole ion. So let me clear one thing to you, that particles means atom, molecule or ion. Okay. Avogadro's number, 1 mole equals to 6.02 into 10 raised power 23 atoms. It means that if there will be 1 mole of atoms, it always contains 6.02 into 10 raised power 23 atoms. That is monoatomic element. For example, carbon. 1 mole equals to 6.02 into 10 raised power 23 molecules. Molecular compound or diatomic molecule, for example H2, O2 or we can say water, H2O. 1 mole equals to 6.02 into 10 raised power 23 formula units, that are ionic compounds. For example NaCl. So Avogadro's number is applicable on atoms, molecules, or formula unit that are ions. We can apply 6.02 into 10 raised power 23 on atoms, molecules, and formula units as well. So students, what will be the formula for number of moles? Here you can see a formula, N equals to m by m. I'm repeating, N equals to small m by capital M, where this small m represents mass in gram, N represents number of moles, and capital M represent molar mass. Okay, so what will be the formula for number of moles? Number of moles always equals to mass divided by molar mass, or we can say number of moles equals to mass in grams divided by molar mass of that atom, molecule, or formula unit. Here from this formula we can also find mass in gram. So mass in gram will become, by rearrangement in the formula, it will become mass in gram equals to number of moles into molecular mass. Okay, we can rearrange this formula, but actually to find out the number of moles for any atom, molecule, or formula unit, the formula for finding the number of mole is always N equals to m by m, that is number of moles equals to mass in gram divided by molar mass. Here some examples are present for number of moles of carbon, number of moles of hydrogen, and number of moles of oxygen. In example 1, for example, if you are given with 3.152 grams of carbon and you have to find the number of moles for this, what will you do? You have 3.152 grams of carbon, and you know that the molecular mass or molar mass of carbon is 12.01 grams. You have to put these values in the formula and you will get number of moles of carbon equals to 3.152 grams of carbon divided by 12.01. So you will get the answer 0.26 moles. So we can say that 3.152 grams of carbon contain 0.26 moles of what? Of definitely carbon. In example 2, number of moles of hydrogen. For example, if you are given with 0.353 grams of hydrogen, how will you find number of moles? You know that the molar mass for hydrogen is 1.01. So you have to put these values in the formula. You will get that number of moles of hydrogen equals to 0.353 grams of hydrogen divided by 1.01 grams per mole. You will divide these values and you will get the answer 0.35 mole. We can say that 0.353 grams of hydrogen will contain 0.35 moles of hydrogen atom. In example 3, number of moles of oxygen. For example, if you have 3.495 grams of oxygen and you have to find the number of moles in it, what will you do? You know that the molar mass for oxygen is 16.00 grams per mole. Put their values in the formula, you will get number of moles of oxygen equals to 3.495 grams of oxygen divided by 16.00 grams per mole. You will get the answer 0.22 moles. So from this we can say that 3.495 grams of oxygen will contain 0.22 moles of oxygen. So students, here is your homework. You have to write the answers of these questions on notebook. Your first question is define Avogadro's number, give an example. And second question is define mole. This was all about today's lecture. Still, if you have any question, any query or any confusion, students, you can ask me during our Zoom session. I will clear your concepts by using whiteboard, slides and different video clips. Till that, take good care of yourself and everyone else around you. Best of luck. Allah Hafiz.